Welcome to your very first chapter of computer science. I'm so excited to teach you this. Today, we will understand how a computer actually works from the inside out. We will cover the hardware and software that make up your computer system, the CPU, memory, input and output devices, different types of software, operating systems, Boolean logic with truth tables and logic gates, number systems with conversions and encoding schemes. This is the foundation of everything you will learn in computer science. Master this chapter and the rest of the course becomes 10 times easier. Let's begin. A computer is an electronic device that takes input, processes it, and gives output. That's the IPO cycle input, process, output. But a computer system is more than just the machine. It has four components hardware, the physical parts you can touch, software, the programs that tell hardware what to do, data, the raw facts that get processed, users, that's you and me. Think of hardware as the body, software as the brain, data as the food, and users as the person eating. All four must work together. Let's understand the two main categories. Hardware is everything physical, the keyboard you type on, the screen you look at, the processor inside the cabinet, the wires connecting everything. If you can touch it, it's hardware. Software is a set of instructions that tells hardware what to do. You can't touch software, it exists as code. Windows, Chrome, MS Word, games, all software. The relationship is simple. Hardware without software is a dead machine. Software without hardware is a no here to run. They need each other. Input devices are how you feed data into the computer. The keyboard is the most common. You type text, numbers, commands. The mouse lets you point and click. A scanner converts paper document into digital images. A microphone captures audio. A webcam captures video. A touchscreen is both input and output. A barcode reader scans product codes. A joystick is used for gaming. For your exam, know at least 8 input devices with their functions. The key idea input devices convert human actions into electronic signals the computer can understand. Output devices shows you the result of processing. The monitor or screen displays text, images, and video. The most common output device. A printer produces hard copy on paper. Speakers produce audio output. Headphones are personal audio output. A projector displays content on a large screen. A plotter prints large engineering drawings. For the exam, remember output devices convert electrical signals back into a form humans can understand. Text on screen, sound from speakers, print on paper. The CPU is the central processing unit, the brain of the computer. It has three parts the ALU, arithmetic logic unit, does all calculations and comparisons, addition, subtraction, and or greater than, less than, all happen here. The CU, control unit, is the manager. It fetches instructions from memory, decodes them, and tell other parts what to do. It does not do the actual work. It coordinates registers or tiny superfast storage areas inside the CPU that hold data being actively processed. The CPU speed is measured in gigahertz, meaning billions of operations per second. Memory is where data and instructions are stored. There are three levels. Primary memory is directly accessible by the CPU. It has two types. RAM, random access memory, is temporary. It holds data while the computer is on. Turn it off, data is gone. That's why it is called volatile. ROM, read only memory, is permanent. It holds startup instructions. Cache memory sits between CPU and RAM. It is a fastest memory storing frequently used data so the CPU does not have to wait. Secondary memory is permanent storage, hard drives, SSDs, USB drives, CDs. It is slower but keep data even when power is off. Memory is measured in specific units and you must know all of them. The smallest unit is a bit, a single 0 or 1. 8 bits make 1 byte, enough to store one character. Then it scales up by power of 1024. 1 kilobyte equal to 1024 bytes. 1 megabyte equal to 1024 kilobytes. 1 gigabyte equal to 1024 megabyte. 1 terabyte equal to 1024 gigabyte. 1 petabyte equal to 1024 terabyte. A text document is a few KB. A photo is a few MB. A movie is a few GB. Your hard drive is probably 500 GB to 1 TB. Google stores petabytes of data. For the exam, memorize the full chain bit, byte, KB, MB, GB, TB, and PB. Software falls into two broad categories. System software manages the computer itself. The operating system, utilities, drivers. It is the foundation that makes hardware usable. Application software. Application software is what users actually use it to do work. Word for document, Chrome for browsing, Photoshop for editing, Tally for accounting. And in between, we have your programming tools, compilers, interpreters, assemblers that convert human written code into machine language. Think of system software as the foundation of your building, application software as the rooms, and programming tools as the construction equipments. System software has three main types. The operating system is the most important. Windows, Linux, Mac OS, Android. It manages hardware, runs application, handles files, and provides the user interface. System utilities are helper programs, antivirus, disk cleaner, backup tools, file compression. They maintain and optimize the system. Device drivers are tiny programs that let the OS communicate with a specific hardware. Your printer driver tells Windows how to talk to your specific printer model. Without drivers, the OS would not know how to use any hardware. Every device needs its own driver. When you write code in Python or C++, the computer cannot understand it directly. It only understands machine language, binary, zeros and ones. Language translator convert your code into machine language. There are three types. An assembler converts assembly language into machine code. A compiler converts the entire high level program into machine code at once, like translating a whole book before reading it. C, C++, Java use compilers. An interpreter converts and executes one line at a time, like a live translator at a conference. Python uses an interpreter. compiler, faster execution, interpreter, easier debugging. Application software is what you actually use every day. It is divided into two types. General purpose applications work for any user. MS Word for documents, Excel for spreadsheets, PowerPoint for presentations, Chrome for browsing, VLC for videos. Customized or special purpose applications are built for specific tasks. Tally for accounting, AutoCAD for engineering or drawings, hospital management software, airline booking systems. The key exam point application software is designed for end users to perform specific tasks, while system software is designed for the computer to manage itself. The operating system has five key functions: process management, running multiple programs simultaneously, deciding which gets CPU time, memory management, allocating RAM to programs, freeing it when done, file management, organizing files in folders, controlling who can access what, device management, coordinating with hardware through drivers, user interface, providing a way for humans to interact with the computer, GUI or CLI. Remember this file with the mnemonic PMFDU. Please make 5 delicious uttappams. OS user interface. The OS provides two types of user interface. CLI, command line interface, is text based. You type command like dir or ls to list files. It is powerful, but you need to memorize commands used by programmers, system administrators, and Linux power users. GUI, graphical user interface, uses icons, windows, menus, and a mouse pointer. Click to open, drag to move, right click for options. Windows, Mac OS, and Android all use GUI. GUI is easier for beginners. CLI is faster for experts. Modern systems offer both. You can open a terminal window inside a GUI. Boolean logic it is the mathematics of true and false. In computers, true equal to 1 and false equal to 0. Everything a computer does, every calculation, every decision, every comparison is built on Boolean logic. There are seven basic logic gates. We will learn each one with its truth table. A truth table lists all possible input combinations and shows the output for each. The NOT gate is the simplest. It has one input and inverts it. If input is 0, output is 1. If the input is 1, output is 0. Symbol is a triangle with a small circle at the output. Expression y equal to not a or y equal to a bar. The AND gate inputs 1 only when all inputs are 1. Think of it as multiplication 1 and 1 equal to 1. Anything else equal to 0. Two switches in series, both must be on for the light to glow. Truth table 000, 010, 100, 111. Expression y equal to a and b and or y equal to a into b. The OR gate outputs 1 and any input is 1. Think of it as addition, but 1 plus 1 equal to 1, not 2. Two switches in parallel, either one on lights the bulb. Truth table 000, 001, 101, 111. Expression y equal to a or b or y equal to a plus b. NAND is not AND. It is an AND gate followed by NOT. Output is 0 only when both inputs are 1. Truth table is the inverse of AND. 001, 011, 101, and 110. NAND is called a universal gate because you can build any other gate using only NAND gates. NOR is not OR. It is an OR gate followed by NOT. Output is 1 only when both inputs are 0. Truth table 001, 100, NOR is also universal gate XOR, exclusive OR. Outputs 1 when inputs are different. 000, 011, 101, 110. Think of XOR as one or the other, but not both. De Morgan's law are two rules that connect and or and not. First law, not A and B equal to not A or not B. In other words, the complement of a product equals the sum of complements. Break the bar, change the sign. Second law, not A or B equal to not A and not B. The complement of a sum equals the product of complements. Again, break the bar, change the sign. These laws are essential for simplifying Boolean expressions and designing efficient circuits. The exam will definitely ask you to verify this using truth tables. A logic circuit is a combination of multiple gates connected together to perform a specific function. To read a circuit, identify the inputs on the left, trace through each gate, and calculate the output step by step. For example, if you have A and B going into an AND gate and the result goes into an OR gate with the input C. The expression is A into B plus C. To draw a circuit from an expression, break the expression into parts. Draw the innermost operation first, then connect outward. Practice is key. Do at least 10 circuits problems before the exam. Number systems. Human use decimal base 10, digits 0 to 9. Computers use binary base 2, only 0 and 1. Octal base 8 uses digits 0 to 7. Hexadecimal base 16 uses 0 to 9 and A to F, where A equal to 10, B equal to 11, C equal to 12, D equal to 13, E equal to 14, F equal to 15. Why do we need different systems? Binary is what hardware understands, but binary numbers are very long. The decimal number 255 is 61 in binary, but binary numbers are very long. Then decimal number 255 is 11111111 in binary. Octal and hexadecimal or shortcuts. They compress binary into shorter representations. X is especially popular in programming for memory addresses and color codes. Converting decimal to binary divided by 2 repeatedly. Write reminders bottom to top. Example 25 divided by 2 equal to 12. Reminder 1. 12 divided by 2 equal to 6. Reminder 0. 6 divided by 2 equal to 3. Reminder 0. 3 divided by 2 equal to 1. Reminder 1. 1 divided by 2 equal to 0. Reminder 1. Read reminders bottom up. 11001. So 25 decimal equal to 11001. Binary. Converting binary to decimal, multiply each bit by its position value, power of 2 and add. Practice these conversions, they will appear in your exam, guaranteed. Octal uses groups of three binary digits. To convert binary to octal, group bits in threes from right. Convert each group 11001001 31 octal 31. To convert octal to binary, replace each digit with its 3-bit binary equivalent. Hexadecimal uses groups of 4 binary digits. Binary to hexadecimal groups in 4 from right. Hexa to binary, replace each hexa digit with its 4-bit binary. From decimal to octal, divide by 8 repeatedly. For decimal to hexa, divide by 16 repeatedly. Same method, different base. Let's do a complete conversation example. Convert decimal 200 to all systems. Decimal 200 to binary. 200 divided by 2 equal to 100, remainder 0. 100 divided by 2, 50, remainder 0. 50 divided by 2, 25, remainder 0. 25 divided by 2 equal to 12, remainder 1. 12 divided by 2 equal to 6, remainder 0. 6 divided by 2 equal to 3, remainder 0. 3 divided by 2 equal to 1, remainder 1. 1 divided by 2 equal to 0, remainder 1. Binary equal to 11001000. Binary to octal 011001000 equal to 310 octal. Binary to hexadecimal 11001000 equal to C8 hexa. So 200 decimal equal to 11001000 binary equal to 310 octal equal to C8 hexa. Verification C8x equal to 12 into 16 plus 8 into 1 equal to 192 plus 8 equal to 200. Always verify your answer. It takes 10 seconds and catches mistakes. Encoding schemes assign numbers to characters so computers can store text. ASCII, American Standard Code for Information Interchange, uses 7 bits representing 128 characters from 0 to 127. A equal to 65, small a equal to 97, 0 equal to 48, space equal to 32. Extended ASCII uses 8 bits for 256 characters. ISCII, Indian Script Code for Information Interchange, was designed for Indian languages like Hindi, Tamil, Telugu. It uses 8 bits. Unicode is the modern standard. It covers every language on earth. UTF-8 uses 1 to 4 bytes per character, backward compatible with ASCII. UTF-32 uses exactly 4 bytes per character fixed length. Unicode has over 1.4 million possible characters. Quick revision, everything in one glance. Computer system equal to hardware plus software plus data plus users. CPU equal to ALU plus CU plus registers. Memory equal to primary RAM or ROM plus cache plus secondary. Units, bit, byte, KB, MB, GB, TB, PB, each into 1024. Software equal to system, operating system, utilities, drivers, plus application, plus programming tools. OS functions, PMFDU. Boolean gates, not, and, or, NAND, NOR, XOR. De Morgan's break the bar, change the sign. Number systems, binary 2, octal 8, decimal 10, hexadecimal 16. Encoding, ASCII 7-bit, ISCII 8-bit, Unicode Universal. Important exam questions. Define CPU and its components. Difference between RAM and ROM. converts decimal 157 to binary, octal, and hexadecimal. Verify De Morgan's law, first law using truth table. Draw the logic circuit for y equal to a plus b into c. Difference between compiler and interpreter. List five functions of an operating system. What is Unicode? How is it different from ASCII? Explain the memory hierarchy with diagram. What are universal gates? Why are they called universal? These are the patterns that appear year by year after year. MCQ self check. Question 1. Smallest unit of memory. Answer bit. Question 2. Which gate is universal? Answer NAND and NOR. Question 3. 1 kilobyte equals answer 1024 bytes. Question 4. Which converts one line at a time? Answer interpreter. Question 5. ASCII uses how many bits? Answer 7 bits. Question 6. XOR output when both inputs are 1. Answer 0. Question 7. Base of hexadecimal. Answer 16. Question 8. Cache memory sits between. Answer CPU and RAM. Score 8 out of 8. You are exam ready. Here is your quiz pin question. Post this at the end of the video and you to comment your answer. The question is convert the decimal number 200 to binary, octal, and hexadecimal. Thank you for learning with me today. Remember, this chapter is the foundation. Everything in computer science builds on these concepts. Master them, and the rest of the course becomes easy. See you in the next session.